In this presentation, we're going to look at counting problems. In an entrance examination in mathematics and statistics, of the 120 students who appeared for the examination, 65 passed in mathematics and 75 passed in statistics and 35 passed in both tests. A student is selected at random, so we're asked two questions. What is the probability that the student has failed in both tests and passed in mathematics given that the student has passed in one test at least? Okay, so what we're going to do here is define our events. M is the event that the student has passed the mathematics test. MC, M complement of M there, or M superscript C, is that it's a fail. And S is the event that the student has passed in the statistics test. And again, S superscript C is a fail. Okay, that's failed in statistics. Now, so what we're asked here is the first question here is, what is the question? It is failed in both tests. Okay, so we want to find out the probability of failing in mathematics and failing in statistics. So that's how we would write it here, that expression there. So MC, or M superscript C, intersection SC, okay? Intersection there, that's the cap symbol, okay? But it's like an A, but you can just sort of, it's okay really to say and if you're new to this, okay? Failed maths and failed statistics. Now, this is a very important expression here, okay? This one here. So this is how we're going to solve it. And really, for the first question, this is the real sort of trick to this question. So the probability of MC and SC is equal to the probability of the complement of S union M union S. Okay, so we have the union of M and S, M or S, and we get the complement of that. Okay, so just notice that this is intersection and this is union. Okay, so when we put it in brackets, it's like the intersection becomes the union. Okay, now it's a complement to that, so we could just rewrite it as follows. Now, this is a sort of big jump here. How did this happen? Where did we come up with this? And this is probably the real sort of real challenge that you have to face with these questions. So what we're going to do is actually look at it from a very, very visual point of view, because actually once you get used to this sort of thing, it actually becomes very, very simple. Okay, but just rationalizing it. Okay, so this is a little Venn diagram that I've drawn out, and in blue here we have M. Okay, now I'm going to break up this into this Venn diagram up into 4 regions. So 1 is everything outside M and S. 2 is everything that's in M and only M. 3 is M and S. It's inside M and S. So it's the union of M and S. And 4 is just in S only, not in the intersection of M and S. So it's sort of, we have 4 little distinct regions there. Okay, so we can actually describe M in terms of how its composition of these regions. So M is the region 2 and 3, okay, there and there. S is the region 3 and 4, okay. And we can look at the complements there. What is the complement of M? It's 1 and 4, okay. And the complement of S is 1 and 2. Okay, and the S is comprised of 3 and 4, in case I haven't said that already. So this is straightforward enough. So what we can do here is look at the intersections. So M and S, what is the intersection of M and S? It's essentially, what do they have in common? It's the region 3. And M union S is like what 4 regions comprise, or what regions comprise M or S, 2, 3, or 4. So it's everything there. And what we can do here is do the same thing for the complements. The complement of M is 1 and 2. So, and the complement of S is, 1 and 4 and 1 and 2. So if we get the union of those, we get 1, 2, and 4. And if we get the intersection of those, we get 1. The complement of M intersection complement of S. Okay, and we can see fairly quickly that this is the complement of that, and this is the complement of that. Okay, so M union S, complement of that is MC intersect SC. Okay, so you probably takes a little bit of a jump to get used to it, or trying to remember a formula like that. But ultimately, it's trying to rationalize this stuff in your head is what we're really trying to do here. So, little Venn diagram approach can really help you get used to this problem very quickly. Okay, so let's go back to the question. Here we go. I think we've broken the back of it there. So essentially, what we have to do here is we have find the union of M and S. Okay, and this is using a standard formula. That's the probability of M plus the probability of S minus the probability of M intersection S. And this is a sort of standard formula. Okay, and again, that's the type of problem that you can sort of look at with Venn diagrams as well. I'll sort of skip past that one there, but we can use the same approach to sort of rationalize what is going there. Essentially, we subtract M union or M intersection S just to prevent it being double counted. Okay, but we're given all the information there: 65 out of 120 plus 75 out of 120 minus 35 out of 120. That means the probability of passing one or the other, which is the union, means that 105 people have passed one test at least. Okay, 35 have passed both tests. Okay, but that means that 15 people have failed both tests. It's the complement of that 105. So 1 minus 105 over 120 is 15 over 120, and that is equal to 1/8. So that is our answer there. Okay, 15 out of our 120 have failed both exams. Now, the second question is, let's read it again. Let's go back up here. The second question is, find the probability that the student has passed in mathematics given that the student has passed one test at least. Okay. So, B is the event that they have passed at least one test. So essentially, I'm just sort of condensing it into another event here called B. Okay, just to make the notation easier to look at. Okay. So it's just a sort of sake of condensing it. So what we're asked to do is find the probability of M given B. This is the conditional probability formula. Okay, and this is something you'll need to get the hang of fairly quickly. Now, B has to be greater than 0. Okay, obviously greater than 0, not greater than or equal to 0. Just to sort of make a mention of that when you write out something like that, that whatever goes down here and the denominator, just have to specify that it has to be greater than 0. Okay, just a more formality of it when you write something like that out. It's just a 100% answer. Okay, now the probability of M intersection B, in this particular instance, because M is a subset of M and B, okay, this can be rewritten here. Okay, M and the probability of M intersection B can be written as the probability of M. Now again, that seems like a little bit of a mental jump there. How do you sort of rationalize stuff like that in your head? Again, you can actually go back to the Venn diagram approach there. Okay, let's go there. Sorry, I'll just bring it up. M is region 2. And B is the region of 2, 3, 4 together. Okay, so what's the intersection of 2 and 2, 3, 4? It's 2. Sorry, 2 and 3. M is 2 and 3, and B is 2, 3, 4. So the intersection is 2 and 3. So it's the probability of M. You can rationalize it very easily. I know it's doesn't come immediately to you, that this stuff, particularly when you're new to it. But that actually is fine to say that. So essentially, what's that there? Probability of M, that's 65 over 120. Probability of B is 105 over 120. So essentially our answer is 65 divided by 105. Well, correctly it's 65 divided by 120 divided by 105 divided by 120. So it's 65 over 105, which is 13 over 21. You can probably decimalize that or express that as a 0.6 or whatever it is. I don't know off the top of my head, but that's the answer we're looking for there. Okay, we'll leave that there.